So for the problems in chapter 12, the gas loop, um, problems were in ID is equal to induced draft and FD is equal to forced draft. So for problem number 1, assume an emergency storage of 10% of the annual coal consumption is to be carried for the plant mentioned in problem 20, Chapter 2, what acreage of storage area is needed assuming square base, slide slope is 22 degrees, depth is 4.57 meters, and density is 888 kilogram per meter squared. Solution for our problem number 1 in chapter 12. So from problem 20, chapter 2, coal use per year is equal to 2.83 times 10 raised to 8 pounds times 1 ton per 2,205 pounds, which will give us 128,345 tons. So emergency storage in the problem, 10% is given as times our coal use per year, which will give us the answer of 12,834.5 tons. Square base side slope is equal to 22 degrees. Depth is equal to 4.57 meters and density is equal to 888 kilograms per cubic meter. So what is required is the acreage of storage area. So V now is equal to W, which is our emergency storage divided by our density, which is equal to 12,834.5 tons times 1,000 kilogram per ton. So the ton units will be cancelled and divided by 888 kilogram per cubic meter. So the kilogram unit will be also cancelled, which will give us a result of 14,453.3 cubic meter. So storage area times depth divided by our cosine 22, which is equal to our V, which is 14,453.3. So deriving this equation, therefore storage area now is equal to 29,324 meters squared, or 0.725 acre. That's all. Problem number 2. An open coal yard has dimensions 36.6 meter by 15.2 meters. How many tons of coal can be stockpiled on it to a depth of 3.05 meters? Side slope is 35 degrees. So solution for our problem number 2. So what we're gonna find here is the coal use per year, or DW. But first we have to solve dV, which is equal to 36.6 meters times 15.2 meters times 3.05 meters divided by cosine 35, which will give us an answer of 20,714 cubic meter. So W now is equal to density times our V. So our density is equal to 800 kilogram per cubic meter times our V, which is 20,714 cubic meters. So the cubic meter unit will be cancelled. So multiplied it to tons per 100 kilograms. So the kilogram will cancel out. Therefore, our coal use per year, or our W, is equal to 1,657 tons. Problem number 3. Select the size of cylindrical coal bunker, 3.05 meters diameter, for holding the 1/2 month coal storage required in a small plant having 1 150 HP fire tube boiler, West Virginia coal fire bank from 5:30 p.m. to 7 a.m. During the day, the average load factor is 55%. Make any necessary assumptions. Solving for problem number 3, so assume our Q sub H is equal to 27,912 joules per grams. Average efficiency is 80%. 1 HP is equal to 33,475 BTU per hour, or it is also equal to 35,316,125 joules per kilogram. So maximum rate of coal consumption is equal to our 100 HP times 35,316,125 joules per HP hour divided by our QH, which is equal to 27,912 joules per gram, times our average efficiency, which is 80%, or 0.8 times 100 grams per kilogram, which will give us a result of 237.24 kilogram per hour. So capacity of 1/2 month, which is equal to 15 days. So in the problem, so the time given is 5:30 p.m. from 5:30 p.m. to 7 a.m., which is equal to 13 hours and a half, or 13.5 hours. So capacity now, solving for our capacity. So 13.5, which is our the hours, and the 15, which is the 15 days, and our maximum rate of coal consumption, which is 237.24 kilogram per hour, and our 55% average load factor, which will give us an answer of 26,423 kilograms. So, solving for volume, our volume now is equals to our capacity times our density. So, our capacity is 26,423 kilograms times our density, 800 kilogram per cubic meter. So, kilogram will cancel it out, which will give us a result of 33.03. Volume is equal to 26,423 divided by 800 kilogram per cubic meter, which will give us an answer of 33.03 cubic meter. So now let's solve for the height of our cylindrical bunker, which is equal to our volume divided by our pi over 4 times our 30.5 meters. This is our diameter. So 33.03 cubic meter divided by pi 4 times 0.3 meters squared. So cancelled, which will give us a answer of 4.5 meters. Problem number 4. Find the length of a suspension bunker to contain 181 tons of coal without surcharge. Width is 4.6 meter. Depth is 4.3 meters. What width of conveyor belt would be the capacity to fill it in 2 hours, running at 45.7 meters per minute? Next is our solution for problem number 4. So the required here is the length of a suspension bunker. So in order to solve it, first we have to solve for the volume, which is equal to 181 tons times 100 kilogram per ton divided by our density, which is 800 kilogram per cubic meter, which will give us an answer of 226.25 cubic meter. So next is our length. So our volume will be divided by our 4.6 meters by 4.3 meters, which will give us an answer of 11.44 meters. So width of conveyor belt with S is equals to 45.7 meters per minute. So tons per hour is equal to 0.000404 SB squared. So substituting our values, so our tons is equal to 181 divided by our 2 hours, which is given in the problem, is equal to our 0.000404 times our width of conveyor belt times B squared. So deriving the equation, so B now is equal to square root of 181 divided by 2 times 0.00404 times 45.7. Therefore, B now is equal to 70 centimeters. So use B is equal to 76.2 centimeters, which is the standard. Problem number 5. Calculate the tons of coal of 800 kilograms per cubic meter density held in a Burkiss-type bunker, 21.3 meters long, 4.6 meters wide, and 4.6 meters deep, with surcharge. So for problem number 5, so solution. So in order to solve for our way, so first we have to solve the volume. So volume is equals to 5 over 8 times 4.6 times 4.6 times 21.3, which will give us an answer of 281.7 cubic meters. So weight is equals to our volume times our density, which is 800 kilograms per cubic meters, divided by 1000, so that the units will be in tons. So input it in our calculator, which will give us a result of 225.4 tons.